How big do you think this room is?
Good morning. Welcome to CES. Welcome to NVIDIA Live. Setting the stage, we are live at the Fontainebleau Theater here in Las Vegas. In just about an hour, Jensen will take the stage to share NVIDIA's vision of where AI is headed. And this panel has the daunting task of warming up this really smart audience before the most legendary keynote speaker takes off. What we will do is first start with introductions, and then we will have a panel of industry experts to talk us through a wide range of topics within the AI ecosystem. So starting with myself, I'm Vivek Arya. I'm a semiconductor analyst at Bank of America Securities, and I'm joined by...
I'm Sarah Guo. I'm the founder of AI-native venture firm Conviction.
And my name is Mark Lipacis, a senior semiconductor analyst from Evercore ISI.
Great, thank you, Mark. So in this first session, we will talk about AI infrastructure, where we are coming from, where we are headed, and we are joined by Sridhar Ramaswamy, who is the CEO of Snowflake. Before I bring in Sridhar, let me just kind of walk you through a memory lane. AI is not the first large deployment in technology infrastructure. We have had the build-out of the internet, the rollout of fiber optic capacity throughout the globe. We have had the rise of cloud computing. We have had a big infrastructure cycle in 3G, in 4G, in 5G. Before I joined Merrill Lynch, I used to work in industry, and I have often lived through the boom and bust of some of those cycles. So that's why it's fun for us to contrast what we are seeing now versus what we have seen before. And it's always risky to say it's different this time. But it is different this time for the reason that in the last 3 years, almost $800+ billion has been spent on AI infrastructure. And if I look at our forecast, close to $600 billion will be spent on AI infrastructure in 2026, right? So that's a lot of funding. The question of where is this money going? What is the return on investment? This B word, the bubble word, comes up a lot. In fact, I was reading Bloomberg yesterday, and they mentioned that just in the month of November, there were 12,000 articles with the word bubble right in them. So in my view, we actually have a bubble in the media headlines that talk about where AI has been going. From my perspective, there are three things that make this infrastructural cycle different. Number one is the fact that there has been seamless adoption. Number two is high utilization. And number three is the amount of funding and the amount of very well-financed capital that is going into this infrastructure. So if we go through these three topics quickly, first of all, seamless adoption. The day ChatGPT was launched in November 22, every person with a PC or a mobile device, and that's close to 5 billion plus users, were able to access that service immediately, right? It was seamless. Unlike some of the prior cycles, the build-out of the original internet, where yes, a lot of fiber optics was deployed, but the end users were not ready. And that is partly why that build-out stopped in early stages. There was a lot of capacity deployed in the core, but the usage, right, only happened over a much longer period of time. So number one is seamless adoption. Number two is the fact that we are seeing very high utilization of this infrastructure, right? Back when I was working in industry, we would talk about the amount of fiber that was being deployed, and then there was a new interesting term that came up, dark fiber, right, which is kind of an oxymoron, because the reason you put fiber is because you want to light it up. So there was all this dark and underused fiber that was in the ground, but what you don't hear is dark compute, right? What you see is all the compute infrastructure that is being deployed is being utilized very effectively, right? Even 6-7-year-old GPUs are being fully utilized, other custom chips are being fully utilized. So that, I think, is another very, very important difference. And to us, if there is one metric that people should watch for, is the utilization of this infrastructure. I think that's far more meaningful metric to measure the success of this build-out. And then the third and final aspect is that unlike the prior cycles, there were a lot of companies that were, let's say, not as well funded. Right? This time, the funding is being done by companies who are generating exceptional amount of free cash flow. If you look at the amount of capex that has gone into the ground, that's only 2/3 of the cash flow of operations from these companies. We think their free cash flow continues to stay positive, but that's another thing to watch out for as another leading indicator to see the success of this cycle. So we think this is the creation of brand new infrastructure. So that's the state of the union, but let's talk about where we are going. And for that, I'm really delighted to bring in Sridhar Ramaswamy from CEO of Snowflake. So maybe Sridhar, let's talk to us about the collaboration you have with NVIDIA. How did that come about? What are you doing? And what are the emerging use cases that you see in the enterprise?
Thank you, Vivek. I live entirely in the software space, so I'm a natural complement to some of the folks that we have on the panel here. And back to your point about high utilization, I think what's very unique about this moment is the many different places where AI is creating value. Even with the old chips, for example, we built a search engine, this was 3-4 years ago, entirely on A10s, which were already not even the top leading models in the world. And so we see a lot of our customers run very large data processing jobs, for example, on smart models running on previous generations of infrastructure. They get utilized. On the other hand, at the very top, foundation models that are leading ones are doing exceptionally well because of their applicability in areas like coding agents, where they are unleashing an enormous amount of productivity. And now you're talking about people that are making easy $200,000-$300,000 every year. And so they're not going to hesitate about spending on a SaaS service that's going to make them more efficient. I think that's why AI is pretty unique in terms of how much value that it's creating. We have launched a bunch of data agents on top of Snowflake. In fact, I have one running right on I access it on my phone. And anytime I want information about a customer, I just turn to it, go, how are we doing with this particular customer? Do we have a relationship? Is it up? Is it down? That kind of access is something that every CEO wants to get to the latest information about how their company is doing. And I think these are the many reasons why you're seeing such excitement in this space. Our relationship with NVIDIA goes back many years. Jensen has actually been an honored guest in 2, I think, of our last 3 Snowflake summits. We collaborated with them very deeply. Obviously, all of our AI products, including Snowflake Intelligence, run on top of NVIDIA chips. We used to train pretty large foundation models once upon a time. We don't quite do that anymore. Those were done on NVIDIA chips as well. We also collaborate with them in the nitty-gritty detail. What are the right embedding models that are going to make search products work much more effectively? And I think the big prize that we are both after is in the future when GPUs can be applied not just to specialized inference on top of foundation models,
right,
but also to things like data computation, which is what we specialize in. So I think we're very much in the early innings of how are GPUs, how is accelerated computing going to impact a lot of things that Snowflake does.
Right. No, I think I'm glad you brought those points up, and I think that kind of ties to the intro that what we are seeing is kind of very strong, seamless adoption, and this is being used in kind of mission-critical infrastructure. This is not, build it and they will come. But when I'm sure there are certain obstacles, right? That there are certain enterprises who are still kind of resistant to the adoption of AI. Mm-hmm. What do you hear from them, Sridhar, and what do you think it'll take to get them over the hump of adopting this new tool?
Look, practical problems are always going to be there. Anytime you have a new computing paradigm, data is going to be sent over to a new class of chips. All reasonable customers, your employer included, have a lot of questions about, hey, what's happening with this data?
Right.
Who owns this data? For example, at Snowflake, the simplest answer that I give every customer is your data is your data. We process it on your behalf. We do nothing else with it. There are questions like that. Part of what people are very finicky with data is data sovereignty. They don't like it when data moves from one location to the other. In a consumer service, ChatGPT can get away with not really telling you where your request is going to be handled. Right. It can be in the US, it can be in Europe, it can be in Japan. It doesn't matter to you as a consumer, but as an enterprise, that's not the viewpoint that you take. You care a lot about where's the data resident, how does sovereignty come in. We often end up dealing with things like micro shortages, back to your point about full GPU utilization, where we have customers in Germany that don't quite have capacity right in Germany, and we have to go negotiate with them about is it okay to send that traffic to Sweden or not.
Right.
So there are these kinds of practical problems that are going to come up, and driving change through an organization. When it comes to day-to-day, how are jobs going to get done? Can you convince people to do them differently? There's no easy answer to that. We have a great sales agent on top of our own data, built on top of Snowflake, but it's an entirely different story for me to tell each and every one of my sellers, you need to be demoing this on your phone every single day. That's a new muscle. They have to learn it. And as leaders, we have to come up with a whole set of techniques for how do we drive usage in a positive way within every organization. That kind of social change is just hard. It takes time.
Right.
In this transition, we have the inbuilt distribution of everybody having a smartphone, a laptop. And so you have this massive prosumer adoption that's really happened. And I think that the enterprise businesses who know how to do change management with these large organizations are really going to benefit this next year from consumers and prosumers having experienced the power of AI for themselves. And so I think Snowflake and NVIDIA and companies that have those relationships with customers are really well suited for that for this next year.
That's right. And we very much think about things like agentic technologies as natural extensions of what we did as a data platform. Why do people bring data to Snowflake? It's because it's easier to manage, easier to get it AI ready, easier to get value from it, and an agentic platform fits right on top of that. I basically tell our CIO or CEO that we deal with, we can put that information in your fingertips. It's an easy sell.
Right. Got it. The one other thing I find very fascinating about this rollout is how it's suddenly becoming more global in nature also, right? It's like you follow where power is being deployed. That's where AI is being deployed. And we are seeing infrastructure come up in the Middle East. We are seeing infrastructure come up in Asia. How is that changing, Sridhar, your kind of go-to-market? If there is more and more computing that is available right across the globe, how does that change your strategy?
So Snowflake runs on top of the hyperscalers. And we have benefited from effectively infinite compute capacity when it came to regular computing. That's what has defined Snowflake's success, because we often rent CPUs on demand. We don't have to make pre-commitments. And so that model actually has carried over on the GPU side. I don't worry, for example, as much about bubbles, because we are not making large commitments. We are not buying hardware. We are not setting up data centers. Neither are our customers. You don't need to make pre-commits in order to use AI and Snowflake, in order to use Snowflake intelligence. It's actually very, very beneficial for there to be large deployments everywhere, because as I said, data sovereignty is very much an issue. In the geopolitical environment that we live in, a customer in Germany wants no part of that data going over to some other continent, let alone or anything else. So I think from that perspective, this build out is very, very helpful, that it is more and more decentralized, and demand for that is going to keep going up.
And how do you see this evolution between open and closed models taking shape? Does that influence, Sridhar, what you do at Snowflake?
It does only in an incidental way, at least right now. And the reason for that is the frontier models, the 4 odd companies that make these amazing models, are so much better than everyone else when it comes to key applications like agent tool calling, like coding agents. And so there is very much a demand for that. On the other hand, as things mature, people want to run them at massive scale, which is where open models become more and more important. The one thing that we all need to remember now as a country, as a hemisphere, is that open models end up influencing developer mindsets enormously. At the end of the day, it's only the few thousand engineers that work at OpenAI that have access to the latest and greatest that OpenAI has, and it's a small environment. What we have seen repeatedly is the power of open platforms to literally attract thousands, millions of developers to work on them, and that can be a positive cycle as well. Even in areas like data center development, which you would not think of as being very amenable to open technologies, Meta, Facebook, the company, did pretty well in open sourcing some of their plans because they wanted an environment in which more and more people adopted that. So I think open source has a huge influence on just developer mindset. This is the reason why closed companies like OpenAI, they actually release open models because they want to be part of that developer ecosystem.
Right. No, I think that's a very good point, right, in terms of expanding adoption. And that's one thing that I also find fascinating about this industry is that in some ways, the growth and the disruption is being led by startups, if you will, right? OpenAI or Anthropic or
That's right.
XAI, right? And they're challenging, right, these really large incumbents, which I would imagine is healthy in some ways.
That's a good thing
right?
for society.
All these large public hyperscalers, they were startups, themselves, right? They challenged the status quo, when they were coming up. So I'm sure it's not an easy fight, right? Many important decisions have to be made, but it's very interesting to look at it, right, from the outside. Maybe Sridhar, one last question from my side. Talk to us about where you are seeing adoption by way of end markets. Yeah, which end markets are more open to adopting AI? Which end markets are kind of, which verticals are kind of lagging behind in their adoption?
It's a fascinating topic because it's very, very broad-based. Absolutely, folks in the financial sector, especially people like asset managers, they tend to lean into technology because they have less regulatory scrutiny, say, compared to a big bank, which just has a lot more to answer to. So the financial sector always leads the way in terms of adopting AI technologies. I would say the sleeper hit in this world has actually been healthcare. You don't think of doctors as rushing over to use the latest tools, but a lot of what they do is tedious work. Taking down notes after every single visit, making sure that they are accurate. And all of us have jokes about, doctors and their inscrutable handwriting. And I think areas like that are also seeing a fair amount of adoption. Is really broad-based this time in terms of the value that people are seeing from AI. And a lot of it, similar to Google search, has been because of the presence of something like ChatGPT that you and I and the 7 billion people in the world that have access to phones can all get to. I think that is really driving a broad-based adoption. And I think what's also really interesting is that unlike Google search, which effectively put out enterprise search, there was no enterprise search once Google succeeded. What I think is unique about this moment is there are all of these interesting applications, like coding agents, that are thriving more in an enterprise context. And ChatGPT isn't really just sweeping the field. So I think that's the other interesting point in terms of the simultaneous growth of both consumer AI as well as enterprise AI.
Right. No, and I see, from our enterprise also that there's a lot of, so-called dark data that is sitting there.
That's right.
Right? That if it is ingested, properly and kind of curated properly, the amount of insights, right, that can be generated from that. So is the missing link, Sridhar, the kind of the productizing of that? Yes, we have the kind of the basic underlying infrastructure in place. Is that how do we take this to actually making a product that is, easy to just click and drag and drop and use? Is that the part that we should be looking forward to?
Also, that's an ad for Snowflake because that's what we do. We make data AI ready, but much more, we also help people put governance on the data. At the end of the day, again, for a company like Bank of America, unauthorized access to data is a very serious problem. Regulators take a very dim view of stuff like that. But part of what companies like Snowflake do is they bring along a governance framework. They bring along long expertise in making sure that the right data is accessed by the right person at the right time. But back to you, I've met lots of customers who will basically tell me stuff like, yeah, we have 20 years worth of contracts sitting in some SharePoint repository. And I generally email some person and say, hey, how about that contract from 8 years ago? They'll come back to me after a week. That's the value that's in front of a bunch of companies to create. And that's what's exciting about this moment.
Right.
Sridhar, thank you so much for speaking with us. It's a great segue into talking about the foundation and the data infrastructure to now the generation of agents and AI applications further up the stack.
Well, thank you, folks, for having me.
Thank you, Sridhar. I appreciate your insights.
Mark, what's your takeaway here?
Well, I think for me, what's fascinating is the expression that you used, early innings, right? And I think about other technology transitions. You think about the iPhone started off with 6 apps. I remember when the PC came out and replaced the mini computer, we were wondering, what are we going to use these things for? Like, are we going to put our recipes on there? Then you had word processing, and then you had spreadsheets and Adobe and all these useful, all these useful apps. And from my standpoint, like, how do you invest? How do you invest to support demand for workloads that don't even exist yet? And it goes to the point that Vivek started out with, the utilization of these processors that are getting deployed is as huge as the spending seems, is 100%. We hear that, and the forecast for CapEx just continues to go higher and higher.
Absolutely. If anybody has dark compute, as Vivek mentioned, maybe you can just share it with Harjot and Shiv and me and our portfolio companies. We'll happily take it and use it. I'm super excited to talk to the founders of Abridge and CodeRabbit now. Thank you guys for joining us. And talk a little bit about 2 areas where we've just seen a massive surge in adoption of AI within verticals and horizontal functions, healthcare and coding. Healthcare, as Sridhar just mentioned, has been a bit of a surprise for those of us who have been looking at healthcare and investing in it for a long time. A bit of a sleeper category, not the fastest adopter, but has proven differently. And coding, I think, has just been the breakout category for the last year. So, Shiv, let's start with you. Can you first just tell us a little bit about what Abridge does and sort of how the capability advances and reasoning and agents have been important to you guys for the last year?
Yeah, absolutely. So we're an AI company in healthcare, and we're focused on automating as much as we possibly can in such a way that we can unburden clinicians from clerical work so that they can focus on the patients in front of them. And just to sort of unpack that problem and that opportunity just a little bit more, there was an article published in a journal a couple years ago, the Journal of General Internal Medicine, that suggested that doctors need 30 hours a day to get all of their work done. And so that's how much opportunity there is for AI to actually seize this moment and for these agentic systems to actually help them focus less on clerical work and a lot more on the person in front of them. The split right now is 80-20, 80% clerical work and 20% face-to-face actual clinical reasoning and thinking and creative work. We think AI can flip the script.
I think all of us have had the experience with an amazing doctor who's spending 80% of his or her time typing in notes when I need them to reason about my case or my kid's case or whatever it is. When you think about the capability advances this past year, what are the things you're most excited about that Abridge is working on?
Yeah, I think that the general playbook that we've gained a lot of conviction on is that we have to do everything we can to fit ourselves into workflows. It's not the other way around. It's not the workflows fitting into these new sort of AI systems. We have to design systems that fit into a pretty complex workflow when you think about enterprise healthcare. So it's not just checking off the boxes in terms of privacy and security. It's also thinking about latency. It's also thinking about all the artifacts that we have to create from medical encounters. And so the playbook that we're getting a lot of success from involves distillation, and it involves fine-tuning, it involves post-training. We're at scale now. We'll probably touch 80 to 100 million lives over this next year. And all the edits that we get on a daily basis, we can learn from, so that we can be that much better for every single clinician in every single specialty in every single setting. So that's what I'm most excited about, is like now we're on to this new sort of inning where we're learning from these edits, where we're continually getting better, and we're also gaining conviction on certain workflows actually being able to go all the way to the end zone.
Harjot, can you talk a little bit about what CodeRabbit focuses on? I think people know that coding agents and coding AI has made rapid progress over this past year, but especially for people who are not developers, who don't run development teams, maybe how does this idea of complex workflows apply to you guys?
That's right. The coding, as you all know, has been one of the biggest use cases for generative AI in terms of token usage, right? Started with a lot of simple tab completion to now fully agentic systems. Now you can think of CodeRabbit as using generative AI to review all that code. Now that given that the volume of code has increased significantly, so we provide a critical trust layer that sits between your coding agents and your production allowing the organizations to enforce guardrails on what goes into production as you're vibe coding a lot of these features. We started around a couple of years back, but this has been like a pretty crazy growth trajectory for us, like used by tens of thousands of organizations, hundreds of thousands of developers, and so on. And we clearly see that in the new world of agentic AI, as the models are getting better, like with Opus 4.5, or you've got Gemini 3 and GPT 5.2, the software agents are really getting great, like in terms of going from a high-level prompt to some sort of like a feature or any application that you're building, right? And what happens in this new world is that the two things become super critical. Like as the inner loop gets solved, the outer loops are where the bottleneck emerges. One is how do you review all that work? That's CodeRabbit. And then the other problem is how do you explain to you specify your intent on what needs to be built? How do you describe your destination where you want to go?
Harjot, what do you, when you talk about developing an AI for coding, like what does it do for the average coder or the excellent coder? Like how do you think about the value add to the different strata of coders?
No, that's a great question. Like what we have seen is now with generative AI, the barrier to get into software development has been lowered. Like you're just going from natural language, English, to any kind of language code that you want to generate. Like earlier, the bottleneck was, hey, I don't know TypeScript, I don't know Rust or any of these languages, and that used to be the barrier. Now that's been significantly lowered. At the same time, generative AI doesn't make a 10x developer become 100x. Like it takes all the great examples that it has been trained on in the open source and brings those examples to a more of an average developer or someone who's just starting out and makes them good enough with code. So that bottleneck has not been removed. So a lot more people are now getting into coding. So a lot of people like fear that, okay, maybe the coding jobs are going away, but that's actually not what's happening. We are seeing a lot more people are now getting into coding. At the same time, we still have to see like whether someone who's been 10x can become 100x. I mean, of course, now they're getting more volume of code getting generated, but then the review and other things are still a bottleneck.
Shiv, you work in an area where all the decisions and the data is really mission critical.
Totally.
I'm thinking about this idea of needing review once you have more speed and other bottlenecks being removed in different fields. How do you think about building trust in the healthcare sector where users are rightfully pretty risk averse?
Yeah, absolutely. Trust is table stakes. And I think it's some combination of transparency, reliability, and credibility. And so from the transparency standpoint, I think being able to build trust in healthcare, it's a pretty high bar. And there's auditability that's involved. There's some amount of transparency involved in terms of how we benchmark our models and how we share those metrics with our health systems. But there's also a lot of work around evals and being able to actually deploy something and then in a pretty organic way share with the health system partner, like this is what we're seeing actually, and we've created any number of LLM judges, for example, that will actually look at the outputs and judge it against the health system's metrics, their rubrics, so that they can understand how well anything is performing. So I think it's not just about that, it's also about credibility, in healthcare, it's about publishing. It's about actually partnering with folks and being arm's length distance from the researchers who are actually going to do some semblance of maybe a randomized control trial to actually assess what is the actual impact here. For us, I think if there is a mantra that we repeat in the company is that we want to save people time. We want to help people be more present with each other. We also want to save the system money. We know that healthcare needs deflationary economics. And there's just so much opportunity for AI to assist, to augment, and to automate, and to actually bring people closer together. And that's something that I think we need as a society more than anything else. But then there's a third act. There's saving lives. There's how do you actually help clinicians make better decisions? Like you were pointing to with your family members. How do you help them actually operate at the quote unquote top of their license, at the top of their own creative stack? And so the stakes get higher and higher as we go farther on this journey, because getting into that world, that space of clinical decision support, involves a lot more hoops. There's a lot more red tape, but it makes sense.
So one of the big buzzwords for this past year that there's a lot of controversy around is just agents and agentic capabilities, especially on more complex, long-running tasks, like both of you face. You're in the real world. You deal with, let's say, grouchy users. You deal with perhaps grouchy, but certainly very careful users. Is agent reliability a solved problem today?
Yeah, it does. I think it depends how we invoke agents versus how we invoke agentic systems. Probably depends on what kind of use case we're targeting. In healthcare, there are high-frequency, low-stakes workflows where an agent can, with the appropriate harness, for example, in the background with access to all the appropriate data, with the right guardrails in place, actually get jobs done and do it behind the scenes, perhaps, without a human in the loop. But then there are tasks, there are jobs that should involve a human, especially in healthcare where maybe like a chemotherapy is involved or some like new diagnostic or therapeutic or some really important high stakes decision is involved. There should be a human involved. And so that's where a lot of our early sort of products have focused, is those sort of experiences where we have to fit into a system where humans are there to check the output and be that last mile.
Yeah, I think in the coding side, it's been challenging and constant evolution, and people are still learning. Most of the use cases where we've seen strong product market fit for these agents has been very interactive use cases. Human being in the loop and having a constant chat session with something like Cloud Code or some of these agents that have now made, right? And the challenge there is like as soon as you go into like background agents where they can run for a longer horizon, the reliability is very, very low. And you would see that in every organization out of 10 developers, maybe 2 or 3 are really crushing it with their cursor usage or Cloud Code usage, while the rest of the engineers are still struggling with the right prompting techniques. And it becomes really challenging because unlike your self-driving cars where you put in your destination, it takes you there, in coding you're describing your destination. And if your description is not accurate, the agent may run for 30 minutes, but you will end up with a lot of slop, right? And that's where like the challenges have been around human in the loop, how frequently those agents should come back with counter questions. And another thing has been like the tool calling formats. Like there's been a lot of discussion around how do you act in the real world. Like sandboxes, for instance, can we generate code to do everything? Like there's a big philosophy and right now that like for every action, there should be code generation behind it, right, to make it more accurate. So those kind of things people are still figuring out.
One question, Sarah, if I may. I'm curious, what is the biggest barrier to adoption in healthcare? Because, right, that seems like such a natural, adopter, right, of this technology. Is it, you think that the underlying technology infrastructure is acceptable? That's not the bottleneck? Is it the delivery of that? Is it that there are certain decision makers who have a natural, to your point, whether it's a regulatory aspect, right, whether it's the privacy aspect. So what needs to be solved for there to be much broader and faster adoption?
Yeah, it's a great question. I think it's not technical. It's really change management, and that's the biggest challenge. Healthcare is an industry that, for a lot of good reasons, has moved slow, but that's not this moment right now with AI. Healthcare is actually moving faster, arguably, than any other industry in taking in AI, and a majority of doctors in this country are using AI in some way, shape, or form every single day that they're seeing patients. So I think the real challenge as we start to, or continue to scale, but also get into new use cases that AI can take on, is going to be around change management. It's going to be around putting new solutions in front of users, getting them used to these very, very fast feedback loops. Nice. The ground is shifting so quickly. Every couple weeks, there's some big improvement. For us, for example, we do a lot more context engineering than we used to. We pull data from not just, say, a medical record system, but maybe from a payer system, maybe from textbooks, and we're engineering that together with a conversation to create output that's compliant, that output that's also clinically useful. And maybe last week's user didn't benefit from that, so how do we get them to retry that solution next week and the week after? And so I think that's probably the biggest challenge. At the same time, I think it is a pretty historic moment right now where it's moving very quickly in healthcare.
One question I'd have for you guys running these scaling AI companies is a change in the environment that's happened over this past year that a lot of folks in our portfolio are taking advantage of is increasing availability of competitive open source models. What is that, how does that factor into your product roadmap or, how you guys think about cost and model vendors?
Yeah, the costs are a big concern, especially in the coding space. You have seen the pricing models were broken very publicly for companies like Cursor and all. Like do you do per seat pricing or do you do usage pricing with tokens and so on? And really good agent harnesses actually use ensemble of models these days, where I would say 12 months back, the open source models were pretty early, but now we are seeing increasing use of open source models in some parts of the harness. Because the question really now for a company like us is where does it make sense to pay a premium for something like Opus 4.5? What are those workloads? And
there was a moment in time where the narrative very strongly in the industry was you can only use the best coding model, no matter how expensive or slow it is, and open source can't catch up. And you feel that's different now?
That has changed now, for sure, right? We have seen really great open source models which have started replacing some parts of even our workloads, like summarization and some of those exploratory, how do you do grep searches on the code bases and so on. So those can be done really well with some smaller open source models, which are very cost effective. And then you have all the flexibility that you could also fine tune to the way of your liking, right? But the premium models still are premium models. If you're going with something like code review, which is a very reasoning heavy use case. So we are one of the biggest users of some of these reasoning models like Opus and GPT-5 on the highest settings. Yeah, but the open source is catching up for sure.
Shiv, everyone knows that coding is a very compute-intensive AI application. You can just trade more compute for better output. Is that true in healthcare? Are you guys a compute-heavy organization or a reasoning-heavy product?
Yeah, absolutely. I think there's the training of the models, but there's also all things related to inference, and that's where NVIDIA's stack is a boon for us, because fitting into the workflow means that there's uptime concerns, there's latency concerns, in addition to all the concerns around accuracy.
Right, inference is a very complex problem, actually.
Yeah, exactly, and you don't get a retry. With patient care especially, the stakes are high enough that we have to help our health systems understand that we're always going to be delivering the most premium solution. Now, underneath the covers, that might look, and increasingly looks like a very bespoke stack. So it looks like our own models that have been fine-tuned for very specific tasks, because that's affording us the latency and the uptime and the level of control that actually lends itself to the kind of personalization, for example, that we're increasingly pushing ourselves into.
And the other thinking in our company has been it's a habit change that we are trying to bring up. Even if we are going negative gross margins for a while, it's the new habits that are forming. So we want to use the best models possible as much as possible.
I will ask you 2 rapid fire questions if we have a minute for it, and I'll put you guys on the spot. One is, does the open source thing work? Is it sustainable? Because I think another part of the core narrative over the last year or two has been in the scaling era, it's so expensive to invest in training proprietary models, open models, that it's only supported by a very few companies. Do you believe that? Is it important for your roadmaps?
It's changing, I would say, especially in the coding space, because everyone has access to the same data. The proprietary models were moving much faster than whatever you were fine-tuning had a very short shelf life. So all that investment in custom data sets never made sense, right? But now we are going into a world where the open source has caught up and some of this training starts making sense, especially on the agent trajectory where you clearly want to guide the agent in one direction or the other on the long horizon tasks. And some of the latency tasks as well. We are now starting to use some of these faster grep models, which search code bases, which are fine-tuned towards that. So yeah, it's interesting on that front.
And Shiv, you guys train?
Say it again?
You train internally
Absolutely.
your custom models, and you don't feel like you need to go spend the budget of OpenAI to do it.
We feel like when there is a new foundational capability that comes out, we need to make sure that we understand it and that we use it if it's going to amount in a better user experience. But the stack and the product is so complicated that it ends up being that I'd say these days, well over half of what we're shipping, at least today, is an in-house sort of product. And so I think the ground is always shifting, and we have to be agile, we have to be dynamic, because the last thing we want to do is ever fall prey to sort of some sunk cost fallacy or be on our heels when something crazy, new, exciting comes out. But at least at this moment in time, and I think at that application layer in vertical industries like healthcare, having more control makes a big difference.
So LLMs have not commoditized then?
I think for vertical tasks, no. I think that there's so much work that you have to do on top of them in order to actually create that differentiation that helps you win.
I have to ask you a question I ask of any successful entrepreneur, which is a very self-interested question, but you're innovative guys. There are, a first cohort of AI native application companies that are working. What do you think is about to begin working? Because I'd say of the current cohort, it's actually not that predictable that the things that began working would work as well as they have, right? You have Harvey, Sierra, HeyGen, Abridge, CodeRabbit, Cognition, it's a whole bunch of different areas, some of which have very difficult users, some of which are more conservative industries, some of which have not been great technology adopters. What do you think is an app area that's going to begin working, or a particular workflow in 26?
Yeah, very clearly, at least from our vantage point, coding is the kind of the gateway to a lot of these use cases. I think that has to be solved first by everyone, and no wonder we are seeing even the model labs themselves investing heavily into coding use cases. Like you've seen Cloud Code and Codex and so on, right? And as you get better with reasoning and the coding, I think a lot more other use cases also open up. As I said earlier, the code generation is kind of a way to do all kinds of actions and actuation, right? And in terms of startups, the opportunities I would say is in the second order effects. Mm-hmm. Like the larger companies like NVIDIA, they're the first order effects. They're bringing up around this change around coding, taking off on the code generation. But for startup entrepreneurs, my advice is usually look at these opportunities on the second orders. What will happen if this happens? And for example, code reviews become a bottleneck. We saw that coming 2 years back. My first startup was also like that, if you remember, Sarah, 10 years back.
Absolutely.
We saw observability will become a bottleneck when your microservices take off. So that's usually how I see the opportunities.
Shiv, what about you?
I think at a higher level of abstraction, this first cohort of companies, I think in some ways has broken the dam. And we're just going to see the same lens that we've all applied and you've applied expertly to startups work really, really well, better than ever before. Really big pain points and really big markets are just going to take off because you can apply these tools in all the different ways. Over these last 2 weeks, my 9-year-old twin boys were using Claude Code to build Pokemon sorting applications. So I think the whole world is going to change probably in record time over these next 12 months. But I just imagine that the same sort of lens that you've always applied to companies we're going to be able to apply again.
Yeah, I think that's a very optimistic note to end this part of the conversation on. Perhaps a less obvious or less clearly right view, agree with everything you said, has been that I've held for most of the last year is actually I think more people will create software than this is something I changed my point of view on over the last few years. I've been who wants to make applications? Only engineers, 25 million of them. Mm-hmm. And I think that's about to change. I think code generation is much more powerful than we think, and it'll end up with your boys and with developers and with a lot more users. Thank you guys so much. Really appreciate it.
Thank you.
Yeah. So Vivek, are we going to use code generation and financial analysis or anything else?
Well, as long as we are the ones using it, and we are the ones that I think we do have access to a number of AI tools, or we are starting to get that access. But I think they're always telling us that make sure that you understand what is being put in, and make sure you understand what is coming out of it, right? So there is still a lot of kind of this co-pilot aspect of, right, that this is not giving you the answer, right? It is helping you generate that answer to some extent. But I do think, it is going to become more commonplace, more as a, driver of efficiency, right? There's a lot of mundane tasks that, Mark can allude to that we do. So I think from that perspective, it's going to help generate a lot more efficiencies.
And I do think it's going to be a really great finisher to our conversation to talk about how reasoning goes from code, the vanguard, to other areas like physical AI.
And that's a great segue to the next segment. So very excited and honored to introduce two CEOs, the CEO of Mercedes-Benz, Källenius, and the CEO, co-founder of Skild AI, Deepak Pathak. There's so much to talk about, and unfortunately, we have a limited amount of time. So before Jensen takes the stage, and for those dialing in on the stream, you can stay on the stream to listen to Jensen's keynote afterwards, so you don't have to find another stream. So Ola, I want to start with you because you have implemented AI both in the factory and in the car, and I believe you were one of the first to get certified, if not the first to get certified in the US for level 3 AV EV driving with Drive Pilot. And I'm wondering if you could help people understand, like, what were the advancements in the technology that enabled you to get to that milestone? Give us a sense. What did it take to get to that milestone?
Well, first of all, great to join this NVIDIA pregame show. I'm very excited to see Jensen's speech here in a few minutes. But this is a journey in terms of automated driving that started already 40 years ago. So the engineers at Mercedes, they kicked off a project back in the 80s that they called Prometheus. And what was their idea? The idea was to make driving safer. But of course, they didn't have the compute, they didn't have the sensing or the sophisticated AI stacks that we have today. And if we now fast forward through all those years, the first driving assistance systems that we launched in the early 90s, where are we now? We're now at the stage where that compute, the sensing, and the brain, the AI stack, can almost solve any one of issues that a car needs to go through traffic. But the key word is here to do it safely and explain to the driver or the passenger what the car can and cannot do. So what was the big step for level 3? Was not just the engineering task, it was also a legal task, because the computer actually takes over. And that's the difference between a level 2 system where the human is responsible and a level 3 and above where the computer is responsible.
And not to get too far ahead of ourselves, but level 4 and level 5, for many people, just can't seem to come fast enough. And I'm wondering, what are the lessons learned from level 3, getting to that milestone? And what further technological advancements do you need in order to get there?
What we're going to see very quickly, and in fact, I had a chance yesterday with the combined Mercedes and NVIDIA team to drive it through San Francisco and down into Silicon Valley, is point-to-point navigation. So a very, very sophisticated level 2 system. Some people refer to it as level 2++, where it feels like the car is on rails. You're just driving and it does everything. I drove uninterrupted for more than an hour through pretty heavy traffic yesterday, actually, on a Sunday in San Francisco, onto the freeway, no problems there, negotiated everything on the freeway, off the freeway, and back into the city again. So that level 2++ that we're launching with NVIDIA here in the States later this year, that's going to come fast. At Mercedes, very fast in many cars. Then you're going to have level 3, and of course you have level 4 robotaxis out there already today, but eventually we will have level 4 private use cars as well, so you can really sit back and relax and the car takes over everything. It's not science fiction, it's not that far away.
And what is as you explain the journey that Mercedes-Benz is taking in order to get there, what is the biggest misperception that you get from people when you talk about this topic?
Well, if you're on the task and you ask the engineering teams that are working on this, to get to the 99% demonstrator is relatively easy. Not easy, but relatively easy. But the long tail of everything else that can happen, that becomes a more challenging task. And that is why safety is key. You can go quick and dirty, but you take then more risk than maybe you would like to take. But if you really want to solve the long tail, there is much more work involved, much more driving involved, much more processing of data involved, much more thinking involved of how to approach this problem. But technology is moving fast, so I'm an absolute technology optimist on this, coming to a road near you soon, at least if you're driving a Mercedes.
Well, I can relate to this because, I plugged a transcript into my favorite LLM to summarize, and when it came back with a summary, it made a mistake. And I pointed it out, and the response was, good catch. Sorry about that, right? That probably does not apply on the road.
No, it doesn't. If you're moving an object that weighs, 4,000 pounds, and it's moving at 50 miles an hour, I think a sorry is not going to cut it. So there needs to be quite a bit a higher level of certainty and safety, as I mentioned, in that equation. That is also why we take the approach. You don't have to rush into the market. You don't have to be the first, but you got to make sure that what you do is robust. And then it's also a question of familiarity. I was looking at a customer study, and it's different in different countries, that If you have never tried it and you never try it, then it's like, you know it's there, but you're not touching the machine. Once you get over that hurdle, and especially I think parking is a no-brainer. Who likes to park? Nobody likes to park. Now that you have sensors, we have in the new CLA that we're just launching here in the States, 27 sensors around the car. It sees in all directions. Any parking situation that you feel intimidating, that car will solve for you. Push a button and the car parks for you. So once you have, as a driver, jumped over that one hurdle, you have used the machine once or twice or a few times, then it becomes second nature. And that's why I think this is going to be, it's going to be a feature that every driver down the road is going to demand.
I want to shift over to Deepak. I'm going to guess, Deepak, that more of our watchers in the audience are familiar with Mercedes-Benz than Skild AI. And so maybe if you could just introduce Skild AI and help people understand what you're doing.
Sounds good. First of all, great to be here. Thank you so much for having me. At Skild, what we do is, in single line, is any robot, any task, one brain. We are building a general purpose brain for robotics. When I say general purpose, it often gets discounted. It's a general AI model, but it's a general model across robot hardware. We put the same brain on a human-like robot, humanoids, same brain on a dog-like robot, quadrupeds, same brain on an arm on an AMR base in a factory. So why do we go so general? There are two reasons we do it. First is, if you think of robotics as an area, what comes first to your mind? Like, if you think of language models, you think of a brain. You think of robots, you think of hardware. You do not think of a brain. But for the last 70 years, for the last several decades, there are so many impressive robotics demos out there. Still, every year it feels like robot will take away my job, come to my home and do my stuff, but doesn't happen. And the reason for that is, what has been missing is a general brain. It is very difficult to work in scenarios where there is variability and randomness in the scene. Second reason for us is, I love Mercedes car, but in the hardware space, whenever there is one product, there are multiple different kind of hardwares which are there, like different car companies, different cars. Even for robots, it's even more true. Like one robot for your factory, one for home, maybe different form factors. You have dog-like robots, more cute robots. With being general across robot bodies, we can leverage data from any source and create this data flywheel, which can keep on fueling the progress in this area.
So Deepak, I think that the industry, the robotics and AI industries together have agreed that data is the problem and why we don't have this brain yet. And so you said you've solved one problem structurally where you can collect from different sources. But what is your philosophical point of view on what it takes, right? Because there's actually, in my understanding, huge dispersion of opinion here, where some people are like, it's world models, we're going to get it all from video pre-training. Some people believe, sim to real, RL, we can solve this problem in simulation. Others believe you need on-robot data collection, and it's just going to be as expensive as it is. Egocentric data, what's the answer here? What's the recipe?
I've been in this area for the last 15 years. I'm also professor at Carnegie Mellon University in robotics. There is no magic bullet, right? Unlike digital AI, like LLMs, like in case of OpenAI, ChatGPT, these language Gemini-like models, there is data on the internet. But there is no data on the internet for robotics. So all this craze about generative AI, we cannot apply to robotics because we are missing the data on which we train these models. So what do we do?
And so implicit in that is video like YouTube is not enough.
No, it is enough, right?
Okay.
So what we do is we have to bootstrap the problem somehow. The golden data is, of course, the robot data, because that's the true data that you're getting. But you don't have the robots deployed, right? So you have to first somehow bootstrap the problem by some means. So what we do is we bootstrap from human videos, right? By watching humans do stuff, like egocentric videos, could be third-person videos from YouTube or Flickr. But watching alone by itself is not sufficient, because if it was sufficient, I could play like Federer. I've watched many of his games. I can play nowhere near him, right? You have to practice and try and fail. But failing millions of times is not possible in the real world. That's where simulation helps us over there. So real human videos and simulation, that's how we bootstrap. And then you create a base layer with that. Then you have to fine-tune that model for a variety of tasks. Let's say for some work in a Mercedes-Benz factory. Then we can collect teleop data in that setup and fine-tune it. So there is no one such answer, but you put them in a recipe to get around the fact that there is no robot data. But 10 years down the line, when there are lots of robots out there getting data, then this problem will hopefully go away at some point.
Maybe one question for Ola, Mark, if I may.
Please.
In terms of the technology hurdles, Ola, is it the level of training and the model building where level 4 and 5 needs to work better at? Or is it what is in the car and the number of sensors and the trade-off between how many sensors you can have versus the cost and the compute requirements? Like, which is a bigger challenge? Or they are both challenging, and where do you think the industry is in kind of addressing those two challenges?
You have to approach both in terms of the sensor set that you choose and the level of compute. And working with NVIDIA, of course, we know we have the best compute. It's also, cost is a factor, but I would say safety is even more important. So we think in terms of redundancies. Everybody knows that an airplane with autopilot and so on has some level of redundancies. And that's how we at Mercedes approach a car as well. You need to have some level of redundancies, especially as you go above into level 3, level 4. Work with redundancies, because what if one system fails? Is there another signal, hence another layer of sensing that is picking up something that creates awareness of the situation and can make sure that you don't make a wrong decision? And as you said, you cannot just go, oh, I'm sorry, I didn't see that object. So I think that's one aspect. But ultimately, to crack the nut, I think it is the data and the learning. So the long tail that I was describing, it is working that. And there is no shortcut there where you can just push a button and now a very smart mathematical model and it's learning by itself and it's all done. You're going to have to go through the hard work as well. You're going to have to do the miles. And if you have, as is our case, 40 different models, those sensors are also going to be in different places. So don't underestimate the additional application that you have for every car when you proliferate this technology. But the basis, your foundation needs to be right. If that foundation and that foundation model is right, you have picked the right sensor set, the right compute, you have all the ingredients there to get it right.
It's interesting, you talk about it seems like you have a task-specific robot in a car, and you're designing for general purpose. And I'm wondering, Deepak, can you contrast, what does that mean, like a task-specific versus a general purpose, and the challenge you have for, identifying the different modalities and this concept of adaptability?
Yeah, it's a really good question and heavily misunderstood at all times. Like, if you look at the example from the language community, I keep going into LLMs because we are in an AI panel here. So in LLMs, before these language models took over, in language field, every application was done in a very specialized manner. You would have a system for search, system for question answering, you have a system for math, system for coding, system for translation. Every single application you can think of, different systems. And guess what? Nobody used those systems. They were all really bad, right? So what was the main finding from this? The main finding was that you had to first go general and then go special. Right? So with these models, we made general model, which can generally write code, generally write English passages, generally reason, and then you can now take these systems, and you can see in many enterprise applications, they take these models, they fine-tune them for their application, which is exactly what we do. Like, we are building this general brain to get the recipe out there, because if you go to one area directly, so cars is special because for cars, people drive car already to go from point A to point B. People love Mercedes car because they like to drive it, right? They are not driving Mercedes. One day they can help Ola to build self-driving. They have been driving it for the heck of it. They like it. But in robots, in other applications, there is no such way to collect data at massive scale. So if you can solve the generality first, then that can help you train these specialized systems with less data, which is the exact finding from these language models. So I would say we are going for a specialized, but with in between a general layer to reach there.
We only have a couple of minutes left. Unfortunately, we could go for an hour. And Ola, I want to come to the other part of AI where you use AI, and that's in the factories. And Can you help us understand, like, one of the biggest questions we get? Are you generating a return on the AI investment that you make? And I'm wondering if you could talk about that. And, and another kind of high-level question I have is, does AI change the manufacturing cost curve?
So when I hear Deepak talk here, I'm excited because I know the work that is going on here in the robotics field, that's going to be one of the biggest, if not the biggest, productivity gain in our factories in decades, or maybe even in 100 years. Because what's happening there is that we're going to have these different types of robots gradually taking over tasks in the factory. And the way you can imagine that, and we already have pilots going on right now, is you have a manufacturing worker doing certain tasks, and in a state-of-the-art automotive manufacturing facility, you have some very complex tasks. But believe it or not, you still also have very simple tasks in logistics where you're literally moving one part from one place to another. Why should we not be able to do that with robotics? It is happening, and I think that already in the next 3 to 5 years, it's like you're going to have your buddy, so you have a worker, but you have your robot buddy, but that robot buddy is a thinking machine. You can talk to that machine, you can give that machine instructions, that robotic person can help you in your task. So this is huge. First baby steps are happening now. So we're testing it on the ground in factories now. But I see this also 3 to 5 years, you walk into our factories, it's going to be a different place. So keep on pushing, Deepak. But it's more than that. Together with NVIDIA and the Omniverse tool, you of course build the factory in the virtual world before you even pour one bit of concrete. So you can have actually produced cars in the virtual world completely before you build the factory. Then you can debug it digitally using AI tools. So once you actually get into the hardware, it's almost like it's perfect. And that will make it also faster and less expensive to build manufacturing facilities. And then you have other AI things which are no-brainers, predictive maintenance and so on, things that will improve quality, improve yield, and so on. That we have been doing for years. Then Omniverse, and the next level in the factory, in the manufacturing space,
just
is going to be robotics.
Just one line to add to this, we are short of time, is that in his example already, like in a factory, which task do I pick if I have to go vertical? Like there are hundreds of tasks in a factory, and if I pick any one task, there are maybe only 3 or 4 people doing it, max. But every task is a bit different from each other. That's another argument why robotics inherently is a general problem.
Deepak, that will have to be the last word. Ola, Deepak, thank you so much. Very exciting developments. We're very excited to watch your progress going forward. And with that, I think we're going to have to wrap it up. For those dialing in on the stream, stay on this channel. Jensen will be out shortly.
Thank you.
Thank you so much.